Kia ora, here's the first part of question 2 from last year's calculus paper. Okay, this is one of these ones where you've got to look at a function and figure out what the gradient function looks like. So it's a little bit hard to do this with the application I'm using, so hopefully you can see it. This is one where you really should go to the NZQA website, get the old paper and practice doing this yourself. And remember also, if you're using the Walker workbook, there's some really great stuff in there on how to do these. So what we've got to do first, we don't have a scale, we've just got x and we've got f of x up here, so y is up here. So we identify the turning points. We also note that this looks like it's a cubic, okay? And if this is a cubic, so f of x is some kind of cubic with other stuff, then we know that the gradient function is going to be some kind of parabola. Now, we don't need to write all of that down formally, but we need to have it in our head because it helps a lot. So, here's my first point that I'm going to spot, is this one here. I've got turning points here and here. So, at those two places, I must make sure that my gradient down here is equal to 0. Okay, so the gradient here is 0. There it goes, and the same thing with this one. The gradient at x equals 1, if we're going to use a 1, 2, 3, 4 scale, is also 0. Now we know we've got a parabola, so the vertex of the parabola will be halfway in between. Now they don't actually require that in the assessment schedule, but we can use that fact to draw a nice parabola graph. So what else can we check? Well, up here we've got a positive slope but getting closer to 0. Okay, so down here we've got a positive slope that hits 0 here, and up here we've also got a positive slope. Okay, so we've got a parabola that looks like this. So there we are, that's that one done. Hopefully your parabola will look a little bit prettier than mine. There we are. Okay, on to the next question. Okay, this question's been fixed up from the exam paper, so I've used the corrected version. We are told that we've got a line and it's a tangent to the graph of this function at this point. We've got to find a and b. So all that is we're being asked to find the equation of the tangent, and then we'll say what a and b are. So f of x is 2x squared minus 3x plus 1. F dash of x, the gradient function, is equal to 4x minus 3. We're interested in the gradient of the tangent when x equals 2. So f dash of 2 is equal to 4 times 2 minus 3, which is 5. Now we're going to use this equation, the point gradient equation, to find the equation of the tangent line. So we know m and we know our point. We substitute in, we get y minus 3 equals 5 times x minus 2. So I'm using the point here for my x1 and y1, and I'm using my gradient of 5. Try and squeeze this onto one slide as usual. So we get y minus 3 equals 5x minus 10. Y, whoops, that's a y, not an x. Y equals 5x minus 7. Now, look what we were asked to do. We were asked to find a and b. So a is going to equal 5 and b is negative 7. So there you go. On to part C. Okay, so we've been given a function. This is it up here. And we've been told the gradient of the graph at the point where x equals 1 is 3. So that means that f dash at 1 equals 3. And we're asked to find the value of a. So we'll start by differentiating. So f dash of x is equal to negative 4 plus 10x plus 3a x squared. And we're going to substitute this in. So we're told that f dash of 1 is equal to 3. So that's equal to negative 4 plus 10 times 1 plus 3a times 1 squared, which gives us 3 equals, we're doing this bit in our heads, negative 4 plus 10 gives me 6. 6 plus 3a, negative 3 equals 3a, a is equal to negative 1. So that's all for that one. Thanks for watching. Next one's coming soon.